packets, where are they? All right, well, I can fix that later. I have a plan B and C. Okay. Okay. Wish I had a podium, but oh well. Okay, one more. Okay, how's everyone doing? Good Friday the 13th so far? No black cats walking under ladders or anything like that? Okay. Having a little bit of trouble with IPv6 on the local network, but we'll improvise when we get to demo time. I've got a VPN I can use, worst case, to get it going. This is kind of an intro talk to IPv6. I'm Mike Andrews. I'm here from Lexington, Kentucky, where we do bourbon and horse racing and apparently college basketball championships this year, so that's a plus. That's where you can find me. And just a little bit about what we're going through here is kind of a 100 level intro to IPv6, you know, what's new, what's not so new, how it works, how to break it a little bit. We'll get into a couple of things that, you know, just kind of reviewing the kind of things you can do to break v4 and what still works and what doesn't. This has been around for a while, but it is finally starting to matter. Seriously, I hope I can convince you of that. I know no one else has been really able to for the last 15 years, but it is starting to matter, I think, and it's worth at least. My goal here is to try to get you at least to look at it a little bit. It might be time to start learning something about it, getting it going in your network just to experiment with. But you know, I'm not expecting you to just completely drink all the Kool-Aid and switch everything over right away, but just get you familiar with it. So, yeah, I don't claim to be an expert on this stuff either. This is something I've been playing with for a while. I've got it running on my network. It works pretty well, kind of neat, and I thought it'd be kind of neat to come and talk about it. I used to be in the service provider business a long time ago in rural Kentucky, doing, you know, back in the dial-up days and a little bit of DSL days, so people out in the middle of nowhere Kentucky could get their spam quicker, basically. Anyone familiar with this picture? Okay, one hand. All right. Okay, we have one Park.com reader in the room apparently. That, unfortunately, that is me. So, and just a quick recap. We're talking about the numeric addresses here. I've tried to explain this to a couple of people, like, oh, we're running out of names. Like, well, no, because as long as there's ways to misspell shit or put, you know, stir at the end of the name, there's going to be plenty of domain names to go around for the foreseeable future. No one's going to run out of creative ways to spell stuff. We're talking about the numeric addresses, which on v4 is, you know, 192.168.1.50. So, a little bit about v6. It's basically the next generation version of IP. It was originally called IP Next Generation. That was creative. So they came up with IPv6, which is even less creative, I guess. v4 came along in 1981 when to replace what was called NCP, which ran on the original ARPANET back in the 70s. So IPv4 came along with 32-bit addresses. NCP, I think, had an even smaller address space. I don't remember a whole lot of the details of it. But they realized that 32-bit addresses were going to run out at some point. I think even Vint Cerf said that the 32-bit thing was supposed to be temporary, but as we'll see in a bit, temporary things have this nasty habit of becoming permanent. And then when you have to go and fix it later, it turns into a little bit of a clusterfuck. So, but we'll see how we can get by with this. Anyway, so IPv6 came along in 1996 as an effort to replace v4, and the goal is to deal with the address space exhaustion issue once and for all, and to put a huge enough address space out there that we really never will run out again this time. We swear, seriously, stop laughing. So, and along the way, we'll fix up a few minor things that were broken or stupid or otherwise quirky about v4, but it's not a complete major rethink of everything from the ground up. It's not like a whole new internet or anything. It's pretty much just tweak. And it's kind of a whole new internet in that it is a different parallel network with a different parallel set of addresses, but there's a lot of stuff that's still the same between the two. Now, it's not, did I see a hand? 5, yes, I'm glad you asked. 5 was, oh yeah, 1, 2, and 3 apparently never existed either. I think there's this, I think that, well, 5 did exist, actually. There's a, I think I've got that on the next slide. Yeah, there's, 5 was an experiment in real-time streaming protocol. I think it's called ST2. There's an RFD out on it. It was kind of, it's kind of like RTSP, but at a lower level, I think. And it basically went nowhere. But it was an experiment. I think the spec is still kicking around. Some people have tried to pump the tires back up and get it going again, but at this point, it's pretty much a death. It was just an experiment, not in a full IP thing. It was just a streaming thing. I think there's a 7, 8, and 9, which are completely different beasts entirely, which also have nothing to do with the mainstream TCP or IP or UDP or anything like that. It's just another thing. So the grand plan with all of this originally was going to be, we'll start rolling this stuff out in '96. We'll get it standardized. Everyone is going to add v6 to their existing v4 network. It's not going to replace v4, and it still isn't yet. And eventually, yeah. But the idea is, first you run them in parallel for a while. You keep deploying v4, you keep deploying v6, and eventually you're going to get to this point where v4 is going to run out, but by the time that happens, most people are going to be on v6 anyway, so it won't matter so much, and you can just turn the v4 network off when it fills up, and everything will be cool. So, sounds like a great idea. What could possibly go wrong? Well, unfortunately, networks are run by people, and people love to procrastinate, and they hate to spend money. And some people got their act together. The OS vendors actually were on the ball on this. Some of the router vendors, not so much. I mean, they rolled it out, but some big name router vendors, like the ones that have a bridge in their logo, rolled it out as an upcharge feature. It's like, we've got it, but you have to pay extra for that feature set, which doesn't really encourage deployment very quickly. They've since reversed course. So if you get the newer software, it's bundled in the base feature set, but wish they'd done that 8 years ago, 9 years ago, 10 years ago. Might have helped a little bit. So, which ends up in a chicken and egg problem where, first you get the mindset of, well, we won't use it because no one else is using it, and then there's, well, our router doesn't support it, so we won't deploy it anywhere else, and it was hard to get everybody on board at the same time. Plus, there wasn't really a killer app for it yet because there was still plenty of v4 space left, and no one could really agree on when the v4 space was going to run out. There were projections all over oh, it's going to be 2005, it's going to be 2020, it's going to be, 2010, and then NAT came along, which slowed the burn rate quite a bit. Everyone just started, instead of people running, /24 subnets to their houses, they just started all sharing a single IP address. That slowed the rate down. .com bubble kind of sped it up again a little bit, then that slowed it down again. Smartphones came along and sped it back up again, so it's kind of, projections on v4 exhaustion are kind of all over the map, and so eventually you get to the point where, it's complacency, it's a Chicken Little effect. Sky hasn't fallen yet. You keep saying it is, but I think you're full of shit. It's not happening, so basically everyone kind of ignored v6 for a while. You go into your kernel config, you compile it out, you just turn it off on your firewall if it actually does support it. So that's how we got where we are now. And like I said, NAT was supposed to be temporary, and well, I'm going to hate on NAT a little bit here because it did significantly reduce the burn rate of IPv4 space, which was nice. It also gives you a stateful firewall as a nice side effect, which is a good thing. But NAT does break stuff. Anyone ever tried to run SIP over IPsec, running voice phones? Yeah, how'd that go? Yeah, pretty much, because SIP was just not designed with NAT in mind. The idea, when you were designing things like this, it's like, well, yeah, it's not going to work with NAT, but NAT's not going to be around for very long. It's just going to be a temporary thing, and v6 will be here in a couple of years, and we won't need it anymore. Yeah, whoop. IPsec, same thing. RTSP, same thing. Anyone remember when you could actually use active mode FTP? Yeah, that's gone. At one point, there was this thing called the end-to-end principle, which, the idea was you'd be able to connect directly from one machine directly to another machine without having to go through any intervening stuff, and that would, enable easier app development. And now you've got SIP proxies and God knows what the hell else. IPsec, you end up having to tunnel it in UDP to make it somewhat NAT-friendly. Did anyone ever played with an AT&T 3G microcell? Hands up. Did anyone actually get the thing to work without throwing it in the garbage and giving up? I almost did, but problem is NAT implementations vary wildly in quality. The 3G microcell in particular, it brings up an IPsec tunnel that's encapsulated in UDP, and the UDP packets are fragmented. So you need a NAT implementation that's actually able to buffer and reassemble UDP fragments, and a whole lot of them don't do that. Oh, even better. Great. Okay, so v6 won't fix that, but anyway, yeah, so my mom has one of those things because she lives in the middle of nowhere, Kentucky, where you can barely get city water, much less cable, much less DSL. So the only way to get anything but dial-up, and forgetting satellite because latency is bad on satellite, the only way to get decent broadband internet was there was a local company who was putting Motorola canopy radios up on water towers. So you could do point-to-point, 1 meg by 1 meg symmetric roughly, which is better than dial-up, but it's not great, but it gets the job done. And it's enough to run these microcells because also being in the middle of nowhere, all 4 major cell carriers have either 1 bar of coverage or none, depending on where in the house you stand. You can start a call next to the window, you walk in 5 feet and the call drops. AT&T, Sprint, Verizon, T-Mobile, doesn't matter. They're all equally bad. So I got her one of these things, and apparently the Motorola Canopy's NAT implementation is one of the ones that doesn't deal with UDP fragments. So, I had to take a sniffer out there to figure out what in the hell was going on. Fortunately, we were able to talk the ISP into switching the radio into bridge mode, and then we run the NAT and the TPPoE on a Linksys E1000, and that took care of the problem. But man, you should really not have to do stuff like this. So, yeah, NAT, it's a neat idea. The stateful firewall is great. Nothing wrong with that, as long as you know which ports you need to open up for your apps. But, the address conservation thing is nice. It squeezed a little more life out of v4, squeezed a lot more life out of v4, maybe more than it should have. But, yeah. Yep, what's up? I'm getting to that at the end, but there is a NAT 6.4 where if you are one of the few people that only has v6 connectivity and no 4 at all, there is a NAT 6.4 that will get you on the v4 internet that way with your 6 only address. Basically just, it's easy to map the entire 4 space into the 6 space. You can't do the other way around though. Okay, why? Renumber stuff? Well, there's automatic stuff in 6 for that, which I'm getting to, which makes it a lot easier. Well, I'll get to it, but there is an automatic renumbering thing in 6 that makes that a whole lot easier if you don't turn it off, which some people will, but maybe that's what the concern is. anyway, so a little bit about how we got here on the v4 stuff is, now in the distant past, IANA, which is Internet Assigned Numbers Authority, they would give out /8/16 or /24 blocks, which used to be called Class A, B, and C. Does everyone know what the slash notation means? Anyone not? Anyone whose hands don't work? Okay. Okay. It's basically a lazy way of writing a subnet mask. So if you have like 192, well, there's an example here at the bottom. So if you've got 192.168.1. whatever on your home network, which most of you do, or 10 something, subnet mask is usually 255.255.255.0, which is 24 ones in a row and 8 zeros, right? /24 just is a quicker way of writing that. The other 8 to get the total 32 is the host number. So you have a 24-bit network number and an 8-bit host number. So you can have 8 bits worth of hosts, or 254 hosts. Yeah. Every address, you divide it into a network part and a host ID part, and that the /24 or the subnet mask, if you write it out the long way, just tells you how big the network part is, and the rest is the host part. In v6, nobody writes subnet mask out the long way, so I had to bring that up now because I'm going to be using it a lot in this presentation. So anyway, IANA directly giving out blocks of just 3 sizes was getting a little inefficient, because not everyone. Some companies needed more than 65,000 addresses, but they sure didn't need 16 million. But some of them got them anyway. HP's got 2 of them. They're consecutive even, because they had I think theirs was, well, they had their own, and then they got one from the smoking remains of DEC when they bought Compaq, who had bought. And Nortel somehow managed to sell theirs to Microsoft for a couple $1 million. Whether they should have been allowed to do that is another question, but anyway. So to get rid of some of that inefficiency, they created 5 regional internet registries. There's ARIN for North America, there's LACNIC for South America, there's AFRINIC for Africa, and there's RIPE for Europe, and APNIC does Asia Pacific. So basically what happens now is IANA gives the /8 blocks out to the regional registries. The regional registries give out smaller blocks that don't fall necessarily on 8-bit boundaries. They can give a /20 or a /18, or I think 20 is as small as they go. In some cases, they might give out a 24, but they try not to. The idea is try to make the global internet routing table smaller by having finer blocks, I guess, or bigger blocks. So, the regional registries give out /20s to companies, ISPs, whatever. And the way this breaks down is kind of like this now. So IANA gets the whole, ARIN gets the entire 207 block. So anything that's under 207, is in North America, which is handy. If you're over in Australia and you want to save space in your router, you can just put in an entire /8 route in your router and get rid of all the smaller routes underneath it, which is really handy. You're going to see a lot more of this in 6 in a minute. Then this ISP, this particular one got a /18, so they get 207.246.64 whatever through 127.whatever. Then one of their customers gets a block of 64 addresses off of that, which is /26, and then with a host number of 0 to 63, you got 10. So that's how the system works now, and now the question is, so when is IANA going to run out of /8s to give to the regional registries, and then when are the regional registries going to run out of space to give to ISPs and stuff? Anyone got some guesses as to what the current projections are now? Okay, someone says they're done. Anyone else? Anyone else got guesses? Yeah, he wins the cookie. IANA ran out about a year ago. So this is why this is actually starting to matter now. Projections vary depending on who you ask on how soon the different RIRs are going to run out, except APNIC already did. It only took them 2 months to burn through stuff because they've got Mostly because you have India and China, and a lot of people over there have smartphones, so they're burning through addresses like crazy over there. So if you're an ISP in Australia right now and you just ran out of IPv4 space, you're kind of screwed. There might be a few things you can do, and we'll get to that in a minute, but when I first started putting this slide together, they were projecting RIPE to run out, I think, this coming Monday, and then I went back and rechecked, and they bumped it out to August. So these numbers are a little bit in flux. The guy that put this together says Aaron did a policy change, and his models for exhaustion are not taking that into account. Whether that means this date is wrong in the up direction or the down direction, I wasn't really able to tell. But the guy, the website there is at the bottom where I got this. Apparently this guy actually works for AppNic, so I assume he knows what the hell he's talking about. So that's the current thing. So next summer, it's going to get real interesting here in North America as far as your ISPs getting more space. Now maybe your provider's hoarding space. I don't know, but so what do we do in the short term? Well, the burn rate estimates vary wildly, as you can see from the last slide. And 4 to 6 weeks per /8 might be right for what AppNic was doing. Of course, now it's 0 because they're out. 10 months per /8 in North America, that's reasonable-ish, I guess, but anyway. Some of the usual suggestions is, why don't we go out to Apple and HP and get them to give their /8s back? Well, yeah, you can, and Stanford did that. Interop did that. BBN gave one back. DoD returned 2 of them. So some people have given their /8s back. Stanford switched out from a /8 to a /14. That was nice. But it's only going to get you 10 more months. It's not a long-term fix. That's the problem. 10 months at best. Maybe only a couple of weeks. There's also the 240 through 254 space, which is reserved by IANA right now. But again, that's only 14 /8s, and a lot of software just dropped that on the floor right now because it knows that it's reserved and it's not going to be usable. And if you're going to change all the software anyway, why not move to v6, right? So, and it's not a long-term solution. So, the long-term solution is moving over to v6, and or you can. The other fix, I guess, is you can try to buy /8s from other people, like Nortel selling their /8 to Microsoft for $7.5 million. Yeah. I think there's going to be a black market in v4 space starting up. I think there might already be. That's going to get interesting. And of course, the more the space gets fragmented, the bigger the routing tables are going to get. Although these days that doesn't matter so much because memory's cheap. But yeah. Yeah, it was a bankruptcy auction. Technically, no. Yeah, technically, no. I think Aaron policy is you're supposed to return it when you're done with it. And so technically, Nortel should have just given it back to Aaron, and Aaron would have reassigned it to somebody else. But $7.5 million. Policies get flexible when money gets thrown around, I guess. I don't know. Yeah, technically, no, they shouldn't have been able to do that. But technically, rules can be broken too, especially when courts are involved and judges are involved and they don't give a shit about Aaron policy and money. So, whatever. The other solution is to just use a lot more NAT. So you get into things like an ISP putting an entire, like your cable company putting an entire neighborhood behind NAT. So every neighborhood gets to share a single IP address. And think about how this phone call would go. Hi Comcast, I'm Joe Customer, and you've got my entire neighborhood on one IP address, but I want you to port forward 6881 just to me so my BitTorrent will run faster. Yeah, how's that call going to end? You know how much Comcast loves BitTorrent after all. So yeah, as if port forwarding wasn't bad enough now, and if you ever tried to explain that to your family, I've tried to explain port forwarding to my mom. It doesn't work. I just go in and fix it for her, and that's fine. But you know, so yeah, you can imagine having to do port forwarding at the ISP level. Yeah. Yeah, but now, okay, so, right. So the analog to that would be your entire neighborhood has one phone number, and you have to call the phone company to set up extensions to your house. Yeah. It's not a good long-term solution, but it's certainly the easiest one to implement. And it's happening already, so get used to it. So that's how v4 is going, and that's why v6 is starting to matter. So let's get into how v6 works. I've already burned up half my time already. So, okay. Trying to speed up a little bit here, halfway through my time. IP addresses are now going to be 128 bits long instead of 32 bits long. That's 4 times the bits, but that's not 4 times the address space. It's that many times the address space because every bit doubles the space. So if you wanted 4 times the address space, you'd be talking 34 bits, not 128. So yeah, there's, you can do 128 bits is, enough to count the atoms in the sun or something crazy like that. I know the ZFS folks over at Sun and Oracle have made comparisons about the amount of energy required to store 128 bits of stuff in a file system would require enough energy that you have to boil the oceans and you still wouldn't have enough. But anyway, 128 bits is a damn big number, so really not gonna run out this time. I'm sure someone will find a way to screw it up, but anyway. 64 is, yeah. Next slide, yeah. But above that, most things are pretty much the same. We still have TCP, still have UDP. You still have ICMP, but it's been tweaked a little bit. Some of the older ICMP stuff that didn't make sense has been ripped out. It's been replaced with new stuff. Port numbers on TCP and UDP, those are still 16 bits. So that doesn't change. You still got port 80 for web stuff. DNS, pretty much the same. SMTP is the same. So hopefully you can, the idea is to start getting rid of that. The way you write these long addresses out is it's 8 blocks of 4 hex digits. So you have 8 16-bit chunks rather than 4 decimal numbers of 8 bits each. So, and since those can get kind of long, there's a few ways to shorten it. You can drop all the leading zeros in each block off. If you have a run of a lot of zeros, which you're going to have a lot of the time, you can just put 2 colons in, and it's assumed that everything between the 2 colons is just zeros. If you have 2 runs of those in address, though, you can only do 1. Most people write the A3F parts in lowercase. Some people do them in uppercase, but it's usually lowercase. If you're writing software that's going to be parsing addresses, you're going to want to do it case insensitive, though. So here's a couple of examples. I've actually used real IPs in these slides instead of private ones, but anyway. So the longest way possible to write Google's IPv6 address is the top one. You drop all the leading zeros off, you get the next one, then you drop the long run, you drop the 3 0 0 0s out to just a double colon, and that's the short canonical way of writing stuff. Loopback address is just 1, so : : 1. That's your loopback address. Real simple. Here's a weirder example because it's got multiple runs of zeros in it. Preferred way, legal but not optimal, and then you can't, there's the not legal way of reducing both runs to 0. Can't do that. So that's the way to minimize the addresses so that they're a little less ugly, and they're still ugly, but you get used to it. If you have to throw port numbers in, since those are usually : something, if you're doing them in numeric addresses, put a square bracket around it so you can tell the difference between what's part of the address and what's part of the port number. Or you can just throw your hands up and throw it all in DNS, where it's a lot more readable. And since you're not having to run that internally, you don't have to run split horizon DNS internally, so do names for your internal stuff. It's just everything's got normal addresses, so you can do internal DNS sanely now, which is nice. So not a lot of reason not to use DNS. We've got some predefined address ranges in v6 that were a little better thought out than they were in v4. And like v4, you've got your private space, which is down in 10, and then there's the 192.168 block, and there's 172.12 or 172.16 through 31, which is a /12. It's just kind of randomly scattered all over. And then the loopback's right in the middle at 127. What's that about? They thought this stuff out a little better at this time around. We also have the concept of site local addresses. We have the concept of link local addresses, which don't cross routers at all. It just stays on your local subnet or VLAN and can't leave it. There are still private addresses. You don't use them as much, but they do exist. So you've got, that's what the site local unicast is. That's like the 10.xxx addresses in v4. FE80 addresses are the link local ones that don't leave your subnet. You don't have broadcasts in v6. You have multicast instead. So there's different predefined multicast targets. There's an all-host address. There's an all-routers address. Things like routing protocols will will multicast to the all-routers link local address rather than sending to some weird 224. Whatever address that it would have been in v4. And then everything else is just a globally routable unicast address. Although right now they're all out of 2000/3, which is a pretty small range. So anything starting with 6, 7, 8, 9, A, and there's plenty of space that isn't even, or not even touching yet. So we got plenty. The way these will work initially is the IANA is still giving stuff out to the RIRs. They're usually doing /12s now. And then an ISP will get a 32-bit block off of that. So that's the first 2 chunks of 16 bits. Then if you're a customer that has multiple subnets, which a lot of them will, you'll get a 48 or a 56. And then every subnet under that is 64 bits long, all of them. So those are the only network sizes you have to worry about. Everything's pretty much 64 bits by the time it comes down to the LAN level, which is really simplifies things. It's first half, second half. Not hard to figure out. If you have a single address at home right now, you're probably going to get at least a /64 from your provider. So everybody gets a whole subnet rather than just individual addresses. Nothing gets smaller than a 64. Even point-to-point interfaces, although there's some debate over that. Some people want to use /126s for point-to-points, and some people say 64 is still a better way to go, even though it's technically wasteful. But there's enough here you can waste it. It just simplifies things to stick to the 64s. Yeah. It's 4 billion times the size of the entire v4 internet. Yes. Yes, it's v4 times v4 for your home network. And here's the same breakdown the way we broke down the v4 stuff. This is 260 is Aaron. You go to the first 32 bits, you get what the ISP got. You have a 48-bit block off of that, 64-bit subnet off of that, and the host ID inside of it. So same kind of deal. Have I lost anybody yet? Okay. I'm trying to speed up here. How we come up with the second half of the address? By default, there's this nice little auto configuration mechanism, so you don't necessarily need DHCP anymore to do address assignments. It's still there if you need it, but by default, you take the MAC address, you flip bit 2 in the first byte, which is the universal local bit. Apparently, there's a such thing as private MAC addresses. I didn't really know this, but there's 1 bit at the beginning of the MAC address that says whether it's local or site local or not. You flip that bit, you stick FFFE in the middle to pad it out to 64 bits, and there's the last half of your IP address by default. So there's an example of a standard taken 48-bit. FireWire does almost the same thing. FireWire does the same FFFE padding in the middle to get its 64-bit addresses, but it doesn't flip the universal local bit. You can still use static addresses. You can still use DHCP, but you don't necessarily need to. Any question? Getting to that. Spoiler alert, Nmap won't even try it. But there's other ways to enumerate hosts in a subnet. We'll get to that. And maybe you can see some issues with having your outbound connections be based on your MAC address. We'll get to that too. So that takes care of the last half of the address. The first half of the address is also auto-configurable because routers will advertise what their prefix is every few seconds. The problem I was having before I started the presentation is the wireless network here is not consistently doing that. It was, okay, well, this morning it wasn't doing it, then it was doing it, then it stopped doing it again. When I started my talk, it was not doing it. Maybe by the time I finish, it will be. If not, I'll bring up a VPN and do it that way. But anyway, these are ICMP announcements that go out periodically. They also, in addition to the 64-bit prefix for that subnet, they also have the MTU for that subnet. So you don't have to do MSS clamping anymore. You just advertise the MTU for that subnet in the RA packet, and you're good to go. You can send out DNS info, although that's a for some reason they didn't do that originally. So some people are still using DHCP just to do DNS assignment, nothing else. Nowadays you don't necessarily have to do that, but not all systems support it yet. Which means, getting to the earlier point here, is that if you do change providers, you can renumber everything without touching individual workstations at all. You just change the routers, and the announcements take care of the rest, and everybody's happy, we hope. So, the MAC address-based auto-config and then the prefix auto-config based on this is collectively called stateless address auto-configuration, or SLAC. Mm-hmm. You mean like other options like Win servers and that kind of thing? Yeah, you can still use it. I mean, I'm actually doing both on my home network. On my home network, my router's sending out RAs with DNS info, and it's running a DHCP6 server. Oh, can a router get it from a DHCP server? Ooh, I haven't seen that yet. No, I haven't yet. Okay. Link local addresses. Everybody automatically gets one of these, even if you don't have a router that's sending anything out. There's always an address that you always get that starts with FE80, bunch of zeros, and then the same modified MAC address trick at the end. So that if you turn on V6, you get one of those no matter what, even if your router's not supporting it or anything. Which means just on your local network, if you combine that with something like multicast DNS, then you can get V6 services running on your local network with literally no setup at all. Might be running it now at home without knowing it. I was, and that's how I started getting into this. Was trying to troubleshoot a problem with this guy trying to do backups, and TCP dump wasn't showing any traffic. I'm like, what's going on? And then finally started sniffing by MAC address, and all this IPv6 traffic is on my network, and like, how the hell did that get there? That's kind of neat and kind of scary all at the same time. So, like, well, I can either kill it with fire, or I can learn about it. And 6 years ago, when the same thing happened, I decided to kill it with fire. This time I decided to learn about it. So, in V4 on Ethernet, you've got ARP, which is what translates the Ethernet MAC addresses in IP. Basically gets you talking on Ethernet by doing a mapping of IP addresses to Ethernet addresses with IPv6, you have neighbor discovery protocol, which does the same thing, except this is ICMP based rather than being its own protocol. It's a little more advanced than ARP. I don't have time to get into everything it does, but it can tell, for example, if you've got like unidirectional connectivity with another host, and it can know not to talk to it. There's a mechanism for doing duplicate address detection in case for some bizarre reason you've got two machines with the same MAC address, or maybe you statically assigned two things the same thing. It's smart enough to figure that out a little bit more gracefully than ARP does. And like where normally you'd do ARP-A to dump the ARP table, there's an NDP command to do that. Or if you're on Linux, since they like to be a little different, there's a command for that on there. And just a couple of other random quick things. Packet headers are a little simple. The checksums have been ripped out, so if you're doing checksum offloading on your NIC, that's not really an issue anymore, which is a good thing because a lot of NICs wouldn't know v6 offloading anyway. That might be a performance issue later on, but yeah, so headers are always exactly 40 bytes, which makes building layer 3 switches a little easier. Just having a fixed length header, and I guess they learned a little something from ATM, even though it kind of flopped having fixed size stuff. But if for some reason you need more than that, I mean, the header's basically just source and destination address. There's a length, there's a hop count, which is used by things like traceroute. There's a traffic class, which is QoS, and there's a flow label, which most people don't use, but it's supposed to be to uniquely identify a connection or a flow. So again, it's supposed to be a layer 3 switch acceleration feature, but a lot of OSs just set it to 0. If you need other options, like fragmentation information, if you're doing fragmented TCP or UDP stuff, there's a pointer in the header to go to an extension header, which goes down in the body area. But the idea is that those are options that you're only going to be using at the host level rather than at the switching level. So all the stuff that the switches need to deal with goes in the main header. All the stuff that the hosts need to deal with is in extension headers in the bottom. Just on link local addresses, yeah. Can be. I was going to get to that in a bit, but it's if you're doing filters on individual hosts in your network, where you're blocking ports just within your LAN rather than on that LAN's gateway. If you've got, like, say, port 139 blocked or whatever, but you don't have it also blocked in v6, yeah, might want to look into that. So yes, it can be an issue if you're not careful with your. That's the main case where it's a problem, if you're doing port filtering within your network rather than on the border of the network. Anyway, fragmentation works a little bit differently on 6. On 4, the routers and the hosts can do it. The way it usually works is if you send out a packet that's too big, the router in the middle will send back an ICMP message saying, that's a little too big, can you resend it smaller, and it'll do that. But on v6, only the hosts do it. So if there is like say if you've got a lower MTU link to the outside, that's why you have the MTU in the router advertisements. So you don't have to go set on each individual machine. And also, so the router doesn't have to deal with the fragmentation overhead. So since all this stuff is ICMP based, including the network neighbor discovery stuff and the router announcement stuff, it's an even dumber idea to just gratuitously block all ICMP on v6. It's a bad idea on v4 anyway. ICMP is there for a reason. Some ICMP is optional, some of it's mandatory. There's a lot of people that just blindly block all ICMP on their firewalls. This is really fucking stupid, don't do it. It's even stupider on v6. So if you need to look up what to filter and what not to filter, go to ietf.org and look up RFC 4890. There's some tips on it. So moving up the stack a little bit, get to things like DNS. DNS is pretty much the same, except you've got quad A records now in addition to the existing A records. They don't replace them, they're just in addition to. So if you're on both v4 and v6, you're going to have one A record, you're going to have one quad A record. which has the longer v6 address. For reverse DNS, you still have PTR records. They go under the dot. Actually, that's wrong. That's IP6.ARPA. Take the V out of there. That's a mistake. It's split up, and it's split up by individual digits. So it's like, you know, digit dot digit dot digit dot digit. They get really long. But the nice way of that, the nice reason for doing that is if you do need to delegate reverse DNS on some weird increment, like on v4, if you need to delegate reverse DNS out to a customer and it's not on a byte boundary, you have to do this nasty hack where you're putting in CNAMEs to PTR records, and then it goes into a different zone, and that's what RFC 2317 explains. It's an ugly hack, but it works. You don't have to do that in v6 anymore. You can delegate down to a 4-bit boundary, not that anybody would do that, but you can. So they kind of went overkill on that. But no kill like overkill. Everything else in DNS is the same because you're dealing with hosting. You know, MX records don't change. CNAME records don't change. It's all just host names at that point, and it doesn't really matter. So let's get on to how you break shit. Now you're still going to need a stateful firewall now that you've hopefully gotten rid of NAT. So the same issues apply there. If you've got the stuff, if you just turn on v6 and you leave it wide open, might not be the best idea. You were asking about filter. You know, what happens if you've got the link local stuff on your local network. If you're doing filters on individual hosts, that could be a problem if it's not checking for v6 the same ports on v6. A lot of IDSs don't do v6 inspection yet. Some of them do, some of them don't. Some of them were just updated to it in the last year. Cisco. Yeah. No. But basically, you're going to need to duplicate your v4 firewall rules onto v6 if you've got open ports. While it's nice to have automatic address assignment based on your MAC address, it does kind of tell the world what hardware you're on, or if you're virtualizing stuff, which hypervisor you're using. You know, all the VMware stuff starts with the same, 24 bits in the MAC address. So if you're hosting stuff in a data center and you're somehow trying to scan for VMware servers, it may not be the best idea to do that. Which is why we have IPv6 privacy extensions, which is a nice little feature where every couple of minutes it will auto-generate a completely random host ID and use that. You still have the current one. You still have the MAC address-based one, but for your outbound connections, it will use the random one, and it will change it every couple of minutes, which is really slick for privacy. I hope you're not doing any access controls based on the complete IPv6 address, because that pretty much hoses that. You can do it based on the whole 64 if this is a home user or something, but so there's pros and cons to it. Privacy extensions are on by default in Windows 7 and in Lion. They're off by default in Snow Leopard and earlier. I don't know about Vista. It's off by default in FreeBSD and Linux, I think, but you can turn it on. It's just an additional, it's just another IP alias that it adds, and then it tags that one as the default for outbound in the kernel. But there's also some firewalls that have there's a policy knob, at least on the Cisco stuff, where you can enforce that the workstation addresses be MAC address based to avoid some spoofing. That's not compatible with this. It's off by default. I see the head desking going on over here. That's off by default, but it's a knob you can turn on, and if you turn it on, you gotta turn this off. Your policy may vary. ARP spoofing hasn't really gone away. Well, it kind of can, but it's just morphed into ND spoofing, where if you start sending out fake router announcements, you can cause some interesting havoc that way on the local network. To try to prevent people from doing that, there's some layer 2 switches that will drop RAs on anything other than the port facing the router, which kind of mitigates things, but there's workarounds for that too, so it's not exactly foolproof. There is something called secure neighbor discovery, which basically adds crypto keys to RA and ND. It's a fairly new thing. It's not widely supported. and you need a PKI to deploy it, which is a bit tricky. So, but it's there. You know, if you want someone to have a certificate before they can effectively ARP on your network, you know, if you want to be that much of a hard ass, hey, you can. It's awesome. So, yeah. Question? Oh, 5 minutes. I'm almost done. Okay. Quick thing about there's a myth going around that v6 is inherently more secure because it's got IPsec built into it. Well, okay. When it first came out, the spec was you had to implement IPsec. You didn't have to use it though. So it's, you know, it's just, they were just requiring that you implement it. Well, who doesn't implement it on v4 these days, other than embedded stuff? So, and that requirement's been dropped because of embedded stuff. But so it's not actually any more secure, other than just being more obscure, and everyone here knows how security through obscurity works, and this is not a so. And as we kind of mentioned a little bit earlier, Nmap won't even let you scan a full /64 because how the hell long would that take? Has anyone tried to scan the entire internet on v4? How many months does it take these days? Yeah, few months. Yeah, multiply that by 4 billion, and you see why Nmap won't even let you try. It might let you scan a /104. I'm not sure. So if you were looking for just VMware systems or just Macs or something, or just you know, or just VirtualBox systems or just Dells, maybe you can do it that way. But you know, there's other ways to get to enumerate hosts on a network, especially if you can get on the local network. You know, if they were stupid enough to leave DNS zone transfers turned on, for example, that always works. Not too many people do that. A lot of people just use 1, 2, 3, 4 for the host ID and just leave the other 60 whatever bits blank. Some people will use the last octet of the IPv4 address as the last byte of the v6 address. And there's some people that go and spell things in hex. 2 guesses as to whose IPv6 address the second example there is. So, yeah, that's real. So, let's see. How else can we break things? I've only got 5 minutes. These last 2 slides go into they're poll talks that are great on all sorts of attacks you can do in v6. I haven't really touched on a whole lot of them yet for lack of time, but how do we get started? Well, operating systems are already covered already. They've had it for years. I mean, if you had a Mac, I think Panthers when they added v6 support, so it's pretty old. XP, you have to turn it on explicitly, and I think you might have to install the driver from the CD, but it's there. It might be there by default in Service Pack 2 and up, I don't know. It's on by default in 7, it's on by default in Vista. Most smartphones support it. I've got an Android tablet that doesn't, but you know, iPhones, iPads, all that, they're fine. Your ISP probably isn't ready. Some of them are. I know Comcast is rolling it out pretty aggressively. Insight's doing it. Allegedly, Verizon LTE stuff required v6, but I've got a Verizon LTE iPad, and it won't give me a v6 address. I don't know why yet, so maybe that was just a lie. Who knows? If you've got a cable modem, it really helps to have a DOCSIS 3 one instead of a DOCSIS 2 one, although I think it's been retrofitted on a DOCSIS 2 somehow. Application software, the standard things like web browsers and mail clients, they're in pretty good shape. There's other things that aren't. I know MySQL, for example, had some, they just now, like in 5.5, really support it well. And well is, for varying definitions of well. We're not able to run it internally yet, but that's about the only thing we can't run internally on 6. Things that we're doing like NFS and all that is fine. How you get your application over to v6, it's going to depend on the language. Some are better than others. I know some people were saying Perl was a lost cause a couple years ago, and then 5.14 came out, fixed that. If you're doing database applications, not a lot of them have 128-bit native data type because it's more efficient to store addresses as integers than as text. You know, 8 bytes versus 39 for a full v6 address. So yeah, and yeah, if your strings do need to be 39 at least, I think, to hold those out. Then the fun part about if you are dual stacked, and if you are dual stacked, what's the connection precedence? If you got both addresses, It used to be you would try v6 with like a really short timeout of a couple seconds. Nowadays, they tend to try them simultaneously, and whichever one responds first wins, and then it tries to cache that. That's the happy eyeballs algorithm. I swear to God, I did not make that name up. Lion does that, for example. I don't think Windows does. Other stuff, good luck. I haven't seen a whole lot of Arduino stuff that does v6, for example, but I think someone did build one that did. Some VPN clients are kind of hit and miss. Our big problem with FARC was load balancers. We had to throw out some long ago end-of-life Foundry gear because it was never going to be upgradable to v6. We ended up rolling our own because no one sells a load balancing appliance with v6 support for under 15K, and you need 2 for redundancy. So we don't have that kind of budget because we're still a pretty small company, so that wasn't going to happen. If you can't get direct v6 connectivity, there's a few ways to, there's some transition technologies. One would be a tunnel. Hurricane Electric does those for free. If you're a home user, I've got one at home. It works. They'll even give you a /48 rather than just a 64, so you got plenty of space to play with. There's other stuff like Teredo and 6-4. Short version, don't. They all kind of suck. World IPv6 Day. Last year, June 8th, a lot of major sites put quad A records in DNS for one day and then took them back out just as a test. And by big sites, I mean Google, Facebook. Twitter chickened out at the last minute, but whatever. We did the same thing, except we kind of left it in there. So we're still reachable by v6. If you just go to www.farc.com, you look it up, you get a quad A and an A record still. This year, June 6th, 6612, lather, rinse, repeat, except they don't turn it off at the end of the day. So it's basically the big launch of v6 for Google, Facebook, Twitter, Microsoft. Akamai is going to do that in a couple of weeks, just to make things more interesting. They're less patient. But the bottom line is, v4 is not going to exactly go away. I mean, you add v6 to your network, but you don't turn v4 off. v4 is probably not going to go away for at least another 10 years. So you got plenty of time, but you might want to start looking at it sooner before Aaron runs out of addresses and your ISP starts to panic and starts trying to do, carrier grade NAT and other stupid shit to prolong the pain a little more. If you do get stuck in a position where you can only get a v6 address, your provider is probably going to run NAT 6.4, so you can still get to the v4 internet, because you can easily map a 32-bit address into a /64 subnet. That's what they do. They have some unique prefix on it. But why not wait why wait and just start learning it now? These slides are up online now in PDF format. All these RFCs are, of course, at ietf.org. And the talk after mine is on what happens when you deploy it on a big network that's bigger than the 15 machines we have. So stick around for that. Should be interesting. And I don't think I've got time for a demo. I was just going to do a little bit of quick web browsing and pinging around, but I don't have time. That's okay. Any other questions? Success. All right. Translation. My talk didn't suck. I'll take that. All right.